In this video on solving trigonometric equations, we will look at equations where we can adapt our understanding of algebra and quadratic equations to solve trigonometric equations that are in quadratic form. So let's look at our first example. Here we have sine squared of theta equals sine of theta. So maybe for a minute, let's think of this instead of sine squared of theta equals sine of theta. Let's look at the equation u squared equals u. Now how would we go about solving that? Because this is quadratic, we would get one side equal to 0 and then factor. So we could factor out a greatest common factor, and we could say that either of those two factors could be 0. So either u would equal 0 or u would equal 1. Now let's adapt that understanding to this trigonometric equation. So let's look instead at sine squared of theta equals sine of theta. And again, we will go ahead and subtract sine of theta from both sides to obtain one side equal to 0. So that would mean that we have sine squared of theta minus sine of theta equals 0. And we could again factor out a greatest common factor of sine of theta. Now pause for a minute and let's just make sure that that step makes sense. If I were to distribute the sine of theta back in, we have sine of theta times sine of theta, that's sine squared of theta. And then sine of theta times negative 1 would yield minus sine of theta. So our factorization was correct. Now, either one of those factors could equal 0. So this means that sine of theta would equal 0. Or sine of theta minus 1 equals 0, which would mean sine of theta equals 1. Now, where is sine of theta equal to 0? If you remember, that is one of our quadrantal angles, and so sine of theta equals 0 at 0 and pi. So if we look at what separates our angles, we can go back and round every pi units and obtain a sine of theta that is equal to 0. So this would mean that theta would equal 0 plus pi k, or simply theta equals pi k. Now as we look at sine of theta equals 1, that again is a quadrantal angle, but this time it's only on our positive y-axis, and so that would mean that theta would equal pi over 2, and the next time we encounter that quadrantal angle is 2 pi units later. And so therefore our answer is theta equals pi k, or theta equals pi over 2 plus 2 pi k. Now as we look at our next example, the thing to notice here is that we have sine squared of theta and we have cosine squared of theta. It would be nice if we could adjust this so that we either have sine or cosine. We don't have a mixture of both. So the easiest way to do this is to use a Pythagorean identity. And you'll remember our Pythagorean identity says that sine squared of theta plus cosine squared of theta equals 1. Now we could shift so that this is entirely written in terms of the sine of theta or in terms of cosine of theta. It doesn't matter, it will yield the same answers regardless. So let's go ahead and write cosine squared of theta is 1 minus sine squared of theta. Now what I just said was simply that we could rewrite this so that it was sine squared of theta equals 1 minus cosine squared of theta and substitute that in. It would not matter. It would yield the same answer regardless. So This means that we have sine squared of theta equals 3 times, and instead of cosine squared of theta, we can write 1 minus sine squared of theta. So now we have sine squared of theta equals 3 minus 3 sine squared of theta. And we can add 3 sine squared of theta to both sides. And so we have 4 sine squared of theta equals 3. Now we can divide both sides by 4. And so this means that we have sine squared of theta equals 3/4. But now we need to take the square root of both sides. And so to take the square root of both sides, we remember that this will yield a positive or negative version of the square root of the right-hand side. So we have sine of theta equals positive or negative square root of 3/4. So what's that mean? This means sine of theta is equal to either the square root of 3/2 or sine of theta equals the negative of square root of 3/2. So let's look at each of these. In sine of theta equals root 3/2, that itself could be in quadrant 1 or quadrant 2. But the reference angle for both of these is going to be, if we ignore the negative, just look at square root of 3/2, what angle has a sine of square root of 3/2 that's acute? And it is pi/3. So in the first quadrant, we have theta equals pi/3, and then to obtain more angles in the first quadrant, we could add 2 pi k. And then in the second quadrant, our angle in the second quadrant would be 2 pi/3, but then we can have any coterminal angle also. Now, let's look at this second equation, sine of theta equals negative root 3/2. If we look at that, and we now are in quadrant 3, pi/3 in the third quadrant would be 4 pi/3. So 4 pi/3, and then we'll add 2 pi k. And then we also have the fourth quadrant. And, well, 2 pi would be 6 pi/3, so we'll back it up, and we'll make it 5 pi/3 to get that reference angle, and have 2 pi k added to that. Now, this will get you all your answers, but now we could do something that's cosmetic and look at opposing quadrants. So, what do I mean by opposing quadrants? If I put all of these angles in one diagram, what would that look like? So our quadrant 1 angle, if I just put the terminal sides on here, there's pi/3. And then what's my third quadrant angle? 4 pi/3. So my quadrant 1 to quadrant 3 is separated by pi units. So if I look at these opposing quadrants, I can add pi to get from one to the other. 1 pi/3 plus pi, which is 3 pi/3. So 1 pi/3 plus 3 pi/3 is 4 pi/3. Add another pi, add another 3 pi/3, and I get 7 pi/3, which is back here. But now I've just added 2 pi to this angle, and so that would yield a quadrant 1 angle with the same reference angle. So quadrant 1 and quadrant 3 solutions could be collapsed simply down to theta equals pi/3 plus pi k. We could do the same thing with quadrant 2 in quadrant 4. If we do quadrant 2 and quadrant 4, quadrant 2's angle, 2 pi over 3, and then 5 pi over 3 are again separated by pi units. And we can go back and forth. So that would yield 2 pi over 3 plus pi k. And there is our solutions collapsed, written more concisely. Now let's look at an equation involving tangent. So here, we can divide both sides by 3, isolating our trigonometric function. And so here we have tangent squared of theta equals 1/3. And we can take the square root of both sides, and that would yield tangent of theta equals positive or negative square root of 1/3. Now if we rationalize that denominator, we have tangent of theta equals positive or negative square root of 3 over 3. So let's take each of these. So tangent of theta equals positive square root of 3 over 3. And then tangent of theta equals negative square root of 3 over 3. Well, this is nice because we again have the same reference angle for both of these. The acute angle that yields root 3 over 3 for tangent is pi over 6. So we can quickly make note of that. The reference angle for both of these is pi over 6. Now let's deal with tangent of theta equals root 3 over 3. So tangent of theta is positive in the first quadrant and the third quadrant. Now if you remember from the previous video, we can use the period of tangent to help us out here. The period of tangent functions is pi, so we can go ahead and say this is theta equals our reference angle of pi over 6 plus pi k. And that will yield both quadrants 1 and 3. If we look now at tangent of theta equals negative root 3 over 3, that would be in quadrants 2 and quadrant 4. So what would the second quadrant angle be? Our second quadrant angle would be 5 pi over 6, and then we can add pi k. And if I add 1 pi, that'll get us into the fourth quadrant. And then I add 2 pi, and it'll get us back to the second quadrant, and so on and so forth. So I cover both quadrants by using the period of this function. And so there's the two solutions, or the infinitely many solutions with the two formulas showing them. Let's look at our next example. Here we have an equation where we can factor the left-hand side. So if it helps, take a step back and write this not in terms of tangent, but let's say u. So 3u to the fourth minus 8u squared minus 3 equals 0. If we were to factor that, we would have 3u squared plus 1 u squared minus 3 equals 0. And we could go from there. But let's go ahead and return to our tangent function. So, how will we factor the left-hand side of this equation? It'll be very similar. So, instead of u, we will write tangent of theta. So we have 3 tangent squared of theta plus 1 and tangent squared of theta minus 3. Don't forget the equal 0. Now we can set each one of these equal to 0. So we have 3 tangent squared of theta plus 1 equal to 0, or tangent squared of theta minus 3 equal to 0. So this means that tangent squared of theta would equal negative 1/3, which means that tangent of theta would have to be the square root of negative 1/3, taking positive or negative that. But this is a negative number, so this doesn't have a solution. So we now look at this equation, and this would mean tangent squared of theta would equal 3, and therefore tangent of theta would equal positive or negative square root of 3. So let's look at that. Tangent of theta equals the square root of 3, or tangent of theta equals negative root 3. Well, tangent of theta in both of these situations would have the same reference angle, namely pi over 3. So, tangent of theta equals root 3 would land us in quadrants 1 or quadrant 3, because tangent of theta is positive there. And again, we can use the fact that tangent of theta has a period of pi. So, this means that theta would equal pi over 3 plus pi k. Well, what about tangent of theta equals negative root 3? That would be in quadrants 2 and 4. We'll use a reference angle of pi over 3 to land us in the second quadrant at 2 pi over 3 plus pi k to get us into the fourth quadrant and back to the second quadrant. And so there are your answers.